Welcome back to class. So we'll continue from the smart contracts that we've written. So we'll start by rewriting the smart contracts. So starting with my terminal, let me clear this one and reopen the terminal. Let's increase the size. Okay. So the folder is inside my documents. So cd documents. Then I will go into the document and get it inside the folder I created for it, which is Web3 CD Web3 Web3 practice Web3 practice. Enter. Then code inside the Web3 practice. I have the file named simple cd simple storage contract. So we'll grab it from there. Simple storage contract. Enter. Then code space dot. So this one will open the file in Visual Studio Code. So it has come. So you can see the counter script, the counter deployment scripts that come with it. So these are the three major files, three major file and one, three major folders and one major file that we discussed the other time. Script, SRC, and test. They are all folders. Then this foundry.tml is a file in the roots of the project. So to write our smart contract, just like what we did the other time, I deleted it from this place so that I can start afresh. So I will create the file again and name it according to the naming system that has been used here, counter.so. So my own will now be capital S simple storage dot so. Simple storage dot so. That's simple storage smart contract. So first thing, the license, capital letter S P. Where is it? Can click on it. Then license. Can click on license. Then identifier. So as the prompt is coming, you can click on it. Then colon MIT. So next is to define our pragma solidity, then shift on top of 6 have the that is power function, so 0.8.2. That's the solidity version we want to use. Then let's declare the let's define the function smart contract. So contracts, we have contracts simple storage. So we'll declare the contract as an object. So press space so that you can type, you can give the object property we want for our contract simple storage. So we start by declaring our variable unsigned integer 256 character is visibility is set to private. So that's what we want to use for our variable called stored value. For this variable, call it stored value. So meaning that we initiate, sorry, we initiate a variable called stored value. We give it publicity, sorry, we give it a view of private. Then unsigned integer 256. So that's the type of data that will enter in this place. So no negative number will be here, and the number will not be decimal. So now, why still inside this object? Why still inside this simple? If you come out like this, there will be error. So while you are still here, you can see this bracket that close the bracket that close this contract, the contract simple storage is this one. So don't go outside the contract. Make sure you are still within the contract. Just press enter like this. So you can see that bracket is shifted down. So meaning you are still inside the smart contract. Now let's declare another space. Now we can declare our we can start to write our function. So function set, we are setting up the contract now. Then what's our uh, input? Our input is going to be unsigned integer of 256 character. Then we want to pass some value, so space underscore value. There will be value that will enter into this place. The value will be integer, it will be 1, 2, or any number. So the value is set to public. So we set the visibility to public, then an object. So the function, what the function will really do, this way we are going to implement what the function will do. This one is just talking about the inputs. The inputs value that will be entering here will be a given value which is of data type unsigned integer of 256 character. So space again. So what's the what's the variable we declare initially here is stored variable. So we now bring it here. So we want that stored. What will be stored? The stored value will now assign this value here. We'll assign it to the stored value. Then stored value. We'll assign the value to store value. So the store value now has become a variable that store a value of data type unsigned integer of 256 character. So we're through with this. So make sure we are still within the smart contract. In as much we are still within this bracket here, we have not come outside this bracket. We are still within the smart contract. So, but we are moving out of this function now. The function we use to set the store value and assign value to it. So we are outside of it. Now we declare another function. Function get. So this function is what we'll be using to get value from the smart contract. So this function will be interacting with this function here to get value that has been stored in this place. So function get, so it's like something we use to fetch. So its own visibility is set to public. Then we want it to be viewable so that we can view it, and we want it to return a value. In the previous code, this is where I made mistake that caused problem. Instead of returns, I type return, because normally in Java it's only return we used to have. We don't have returns, but in Solidity the function with return will be declared with returns. To return something in a function, you declare with returns in declaration, but when you are implementing it within the function, it will return. It will be normal return. So returns. Then what do we want to return? the thing we are returning is inside object notation again. No, I've made a mistake. Control Z, Control Z. So returns. What are we returning? What are we returning? Returns. So that return we pass it as a function, then we put an input for what we want to return. What we are returning should be unsigned integer of 256 character. Then we now define the object itself. 256 character. So we now return what we actually want to return. What do we want to return? Stored. We want to return this stored value. So, but this stored value now is now whatever value that is here. So, stored value color. So, this is it. We are through with the smart contract. So, let's compile it. If we are successful this time around, we will not have error like we have the other time. So, forge in this terminal, we now use the command forge build. Press enter. So let's see. Successful. So our compiler runs successfully now, meaning that our smart contract has been built and it has been compiled and built. So you can see out folder now. An out folder has been created, and if you check inside the out folder, we have that smart contract. What's the name? Simple Storage. SimpleStorageContract. So this is the file that is generated inside the simple storage. So we now have .json. We have a simple storage.json. So this is auto generated, and don't add code it by yourself. It's generated by the compiler. So and you can see it's in form of the object is in form of 256 character unsigned integer 006 times and the likes. So this is a machine language. It's a kind of it's not purely machine language, but it's meant for compiler to actually interact with the smart contract. So this has been done. This one is successful. So the next thing is for us to go and write our tests. So after writing, we have written the smart contract and it has compiled. Now let's go to the test folder and write our tests. So in the test folder, let me close this. So that you won't be confused. Alright, so we now go to the test folder. Inside test folder, create test file. So the test file is named SimpleStorage.t.sol. SimpleStorage.t.sol. Let's check the okay, you can see counter.t.sol. So our name is correct. So first thing, our SPDX license SimpleStorage.t.sol is correct. So SPDX license identifier then colon space MIT. Then our pragma solidity. I think there's network. The thing is supposed to be auto detecting what I'm typing. It may be network issue. 0.8 0.20 colon semicolon. Press enter twice. So the next thing is for us to import. What are we importing now? We're importing uh, Forge standard for tests. So we import Forge standard for testing, test.so, semicolon. Then next one is to import the test itself. Import. Always remember to put this string notation. So the next one is import. So this one we're importing from the folder inside the SRC here. So it's inside SRC. We're importing this simple storage smart contract. So import dot dot. So the dot dot stand for the higher level of the uh, file of the folder that we have for the project. So from this we move down to SRC. Then from SRC we now move down to simple storage dots. So slash SRC slash simple storage dot so. So we have imported our smart contract into this test file. So next thing, we'll define the smart contracts that we actually want to test. This simple storage smart contract. This simple storage contract, we'll define it. Then we'll now use setup to set the environment for the test to run. Remember the use of our setup and teardown. So contract simple storage simple storage tests. Simple storage test is tests. So to let the Forge know that this is the tests we are interested in. It's tests. Then the object notation inside it will now we initiate the simple storage. Simple storage, we initiate it as a storage contract. As a storage contract. As a storage contract. Such that we now have function, we define function setup. So these are setup. Remember setup and teardown. So setup, make the visibility to be public. Then the object notation. This is the formal way of writing function. You will see all our functions are having this object notation. So that is the standard way of writing function in Solidity. So here we'll pass a constructor storage contract. So storage contract will be every new instance of simple storage that we are testing. Every new instance of simple storage that we want to test. Then so here we have defined storage contract to be every new instance of, such that if later we are updating the state of the value, if later we update the state of the value, the new storage contract will also update in the next call. So we now move on to function. Okay. So function. Now the test itself. this one is the what we have done with setup is just to prepare the environment. So the test itself, we are yet to grab it. So that's what we are doing now. Function test. So let's say our initial value is 0. So function test initial value. Please take note of the case. Uh, take note of the letter case we are using. Where we use capital, where we use small, such that it will not give you error. Is and no space. Test initial value is 0. So meaning that we are starting our storage with 0. The first thing that we have in the store is 0. So visibility is set to public. Then object notation for complete, for making it an actual, for making it a function. So inside the inside this function, what we intend to do here is to give the initial state of our storage, to give it 0, such that it will start from reading 0. So and we'll do that by we are going to give we are going to define the data type to be unsigned integer, because that's the data we are using in the contract. So unsigned integer of 256 character of 256 character. So that will be our value. So our value will be assigned integer of 256 character. So at initial, we want this value now to be what? We want the value to be 0. So and remember, the value is what we pass. The value is what we have assigned to stored value. We've assigned the value to stored value, and the stored value is actually inside what is inside our storage contract. Let's get back to test here. Since the store value, this simple storage contract now has been the environment has been prepared for it as a storage contract. So it's now storage contract we'll be using instead of simple storage from now on. So now say unsigned integer 256 value equals to store storage contract dot get. So we want it to get this value and use it to update the initial state dot get. Then what do we want it to get? Dot get. We have not defined that, we'll define it. Then we now use assert. We don't want it to get anything different from that, so we now say assert equal, make sure what you get is strictly this. Assert equal, then we pass the value. Remember the value here, so we pass the value to be what? Should get value of 0. Should get value of 0. So semicolon. So we are through with the function here. So what this function will do is that it will pick 0 as a value and make sure that's the only thing that the, because of the assertion, that's the only thing that the contract will get, and pass it to what? And pass it to this value. So this value will return it to the smart contract that we are testing. So our initial state now, or what is firstly stored in the storage, is now 0. Now, if we test now, if if the smart contract behaves the way it's supposed to behave, then it will give us output of 0 as what is in the store. Now, let's look at a situation where we test for different cases. So this one is testing for when we check the initial state. Now, when we want to check for a situation where we store another thing, let's say 0 is there before, we now bring another number like 100. So is the test able to store, because we want the smart contract to be storing, so will it be able to store the 100? So let's now use another function to uh, actually test for that. So function. So if you remember in our testing, we said that we always mock. So this example of mocking. So we're the one that think of zero. We now use it to pass the zero for the as what to be stored. So it's an example of mocking is testing. We are the one that passed the zero for it. So the function we want to do here, we want to use it to set a value. So function test set value. So in a situation where we set another value for what is here already, set value, we set the visibility to public, then object notation that completes a function. Then inside the function, what the function is to do, we want our storage uh, contract, to do what? To actually set. So storage.set. We don't need to bother with defining the integer again because the smart contract has already stored 0, which is type of integer. So if you don't pass another data type, it will still be expecting the previous data type that has been sent to it. So that's why we don't start with this again. So storage contract does set. Now what do you want to set for it? So the set, we want it to get a value. So the value now, give it 100. Let's say we want it to get 100 as a value. So column, then space, then space. I think there's error somewhere. There's error somewhere. There's error somewhere. Contract simple storage. Because at the end of the day, it's like we are now outside smart contract test. Let me check. Contract is function set public. Set public storage contracts, new storage, new simple storage contract. This. Oh, there's error. There's error. So after this is what I'm trying to check. The first function, when we start the storage test, everything should be inside the storage test. So this thing that is here, supposed not to be here. If I don't remove it now, it will cause problem later. So let me clean it. So what I'm saying is, the initial uh, brackets for this, the initial object bracket for this contract test declared here that we initiated here. So that thing should be the one. I mean, the closing of this initial bracket here, supposed to be the last in this place. So by the time we finish here, supposed to have two brackets. Supposed to be the last here. So that means at a point I've moved outside the smart and the test. So it will tell me that it cannot test the test outside the smart contracts cannot be free. So to avoid that, so the this opening bracket here, this is closing now. You can see because I click on this. As I click on this, it highlighted this. So it will go and highlight this closing bracket. So and you can see it has highlighted it. So this is closing bracket. So meaning this bracket, this is own closing bracket. So always check for this kind of error. But later, for this function, this is the opening bracket, this is the closing bracket for it. Then for this one, this is the opening bracket, this is closing one. So you can see. So before I've made a mistake. So this function is not outside, it's within this this function here. Look at it from here to here. It's within the tests, because this simple storage tool is a contract on its own, but it's used for testing. So this function is inside this uh, simple storage test contract. Then if you look at it, the other function too should be inside it. Then look at the next one. This function too should be inside it. So by the time you now have nothing again after this, that means this function will be outside. So please take note. If you made a mistake, you need to correct your own. Now let's go back. So after we set the value to 100 here, so we'll now assert equal such that what we get will be exactly what we store. So assert equal storage contract dot get. So what do we expect it to get? We expect it to get 100, that we set it to update the initial state of the smart contract. Okay? So by this we are through the smart contract. Control S if we are using in my case is Command S. What matters is save it. So we now do forge test to check if our test will run for our test to see to test our smart contract. So forge in the terminal and use the command forge test. Wow, line 22. Line 22. Expected colon. Oh, sorry. So if I type space, colon would now come to 22, but it's at this point that is expecting colon, and I didn't put it. So command S, I save again. So let's rerun it. Forge test. That's it. So we ran two tests, and the two tests passed. So what are the tests? The first test we pass is that test initial value is 0. So we test for initial value if it's going to be 0, and it pass. Switch results okay. So our initial value is 0. So you can see gas. This is the gas used in this contract, although it's free, but I think we have to pay. We actually pay for this amount of gas, 7,910. Then the second one is to test set value. To test set value, we have gas of 29,143. So the second two pass. So these two are the tests we actually carried out. This is the first test. We tested for when we set initial value, and we tested for when we update the storage, when we add more thing to what we have in the store. So this one, all what we do here is just preparing the environment for the smart contract.